Don't know about you folks, but I find this whole lockdown thing. Some days I'm really not very happy. Some days I'm happier. Today, for some reason, I'm in a very good mood. It may be listening to sad songs that does it. Sad songs always cheer me up. Don't know why. But today, to get on to the point, we're looking at definite integrals. Now, this is where we start to get towards pretty quickly, quicker than we did with differentiation. Something that's really quite useful. What we're going to learn today is going to help us on the next lesson to find the areas under curves. So it's very important. Definite integrals. So this is about finding things between two specific points or two specific values of x. Right, so as you're jotting this down, definite integrals, I wonder if you can spot something that's a bit different to what we've had before. And that is that we've got a 1 up here and a 0 down here, which means we're going to be thinking about this expression and what happens with it if it were a function between the values x values of 0 and 1. First of all, we're going to do the same thing as we would do normally, just going to integrate it. So you might want to have a go at that before watching me do it for you. Before you can integrate, this is in a bracket that's been squared, so we need to expand that bracket. So we could do that with a trusty old grid. And when you multiply, add the powers, don't you? So that's going to give me power of 2/3. I'm going to have negative x to the power a third there, negative x to the power a third there, and minus 1 times minus 1 is plus 1. So that's going to give me x to the power 2/3 minus, we've got two of those, haven't we? 2x to the power a third plus 1 dx. So this is what we're going to have to differentiate. When we do that, because we want it between x values of 1 and 0, we're going to put it into square brackets. The reason why will become clearer over time, one of those things you get used to. Right, so we've got x to the power 2/3, and I'm going to be adding 1 to the power to give me 4/3 there. I'm then going to be dividing by 4/3. Well, when I divide by 4/3, I times by 3/4. So as it's 1, I'm just going to write 3/4 there. Then if I add 1 to the power here, I get 4/3. I've made a mistake, haven't I? That should be 5/3, shouldn't it? Because you have to add 3/3 to add a whole. So that will become 3/5. Sorry if that's made a mess of your notes, as it has done of mine. Then we're going to be dividing by 4/3 over here. So I'm going to write that as 2 over 4/3 and deal with it separately. And then we are going to be adding 1x, add 1 to the power, don't we? So divide 1 by 1 gives you 1 anyway. We do not have to do a plus c when we're dealing with definite integrals, and I'll touch on the reason why later, if I may. So then we've got this. Now I need to sort this out, don't I? So before I do anything else, just come to one side and do that. So I've got negative 2 divided by 4/3. It's going to be the same as negative 2 times 3/4. Cancel that there. It gives me minus 3 over 2. So I'm going to have 3/5 x to the power 5/3 minus 3 over 2 x to the power 4/3 plus x, square bracket, between the x values of 1 and 0. Now what we're going to do is we're going to find out what the function is worth when x is 1, and then we're going to take away from it what the function is worth when x is 0. And because that will give us plus c both times, we'll have c take away c, That's why the c disappears. And we didn't need it in the first place. So we'll go on here. So I'm going to do power of 1 first. So if this was 1, 1 to the power 5/3 is 1, isn't it? So I'm going to have 3/5. 1 to the power 4/3 is 1, so that's going to give me 3/2. If it was a more tricky value, just stick it in the calculator, find out what it is. And then x is 1 there, isn't it? And I'm going to be taking away from that 0, because if you put 0 into that, you get 0, 0 into that, you get 0, 0 into that. At this point, let's just pause and think about c. If I had put plus c on there, I'd have had plus c on there, wouldn't I? And I'd have had plus c there, and I'd have been taking that plus c away from that, so it disappears. That's why we don't need to worry about it. Now, let's sort out what all this is worth. If I do 3/5 take 3/2 plus 1, I could work it out, or I could just whack it in the calculator, which is what I've just done without showing you. Gives me 1/10, and all of that is nothing, isn't it? So our final value there is 1/10. We've done it. Just one more example today. If you'd like to write this question down, and by all means have a go at it before I explain anything if you like. If you'd like one hint that's coming right now, that would be that you're going to want to integrate this and work all of this out before you worry about the 4p squared bit. So the expression that needs to be integrated to 2px plus 7, do that first. Don't worry about the fact that it's a capital either. So when we do that, we're just looking at this bit first of all, and we're going to say that we want to integrate this, don't we? And we're going to have a nice big bracket on it. That's going to become x squared, which means we're going to divide 2p by 2. So 2 divided by 2 is 1, so that's just going to leave me with px squared. And then we're going to have 7x, and we don't need to worry about the plus c. And we're going to have that between x values of 5 and 1. So to work out what that is, we need to substitute x as 5 into this first of all. So p times 5 squared plus 7 times 5. And then we're going to be taking away from that x substituted by 1. So that'll be 1 squared is 1, isn't it? So that just gives me p plus 7. So let's write that out again. We're going to have 25p plus 35. Then we're going to be taking away p plus 7, which means we're going to take p and we're going to take 7, doesn't it? And if I simplify that, I get 24p plus 28. And at this moment, I'm going to remember that this was all equal to 4p squared. So I'm going to say that that equals 4p squared. And now we've got a quadratic. So if I take the, or if I keep 4p squared there, and then I take 24p and take 28, I've got 0 on the other side. Now before we factorize, notice that 4 goes into all of these, so we can divide everything by 4 to give us p squared minus 6p take 7 is equal to 0. And then factorize that, multiplying to make a negative, so I'm going to have a minus and a plus. What multiplies to make 7? 7 times 1. We've got a negative coefficient there, so the negative is the 7, the positive is the 1. And that means that p is equal to 7, or P equals -1. And that's that. Now I can hear you all saying, "Sir, let me practice some of that." So yes, you may practice some of that. Page 297, exercise 13D, question 1 and 2 gives you a load of practice of just sort of doing the basics of it. And then you've got some exam style questions, and the last question being one which gives you a little flavour of how it might be used in a slightly practical situation. Okay, a bit of mechanics going on. Right, well, enjoy all of that and see you all again next week, folks. Stay safe. Bye bye.